This is a very important topic which is usually asked in the exam, and this topic is undesirable effects of eddy current. Alright, so we know this eddy current, it is usually produced in the bulk of a metal when there is a changing magnetic flux that is linking with it. Now, the eddy currents which are produced in this case, it cause an unnecessary heat, okay, and hence a wastage of power. Okay, so like in the core of the armature of an electric motor or of a dynamo, or we can say in the core of the transformer, then there is always an eddy currents. So these eddy currents in this core, they will produce a lots of heat, and as a result, the that transformer, or the core of the transformer, or the core of the armature of the electric motor may damage. All right. So hence, in order to avoid such a problem, or to minimize, I can say, the eddy currents, then what we do is, instead of a single solid metal, then we divide this single solid metal into a thin sheet of metal. And each sheets of metal here are being insulated from each other by a thin varnish. And so we call these thin sheet of metal as, as a laminated core. Okay, so these laminated sheets of metal here, they will, you know, produce a large resistance to the eddy current. So when the resistance is large, then we know current is small. So because of large resistance, then the amount of eddy current which is passing through this, or which is induced in this metal, will be less. All right. Okay. Now, after this, we will come to the uses of eddy currents. There are many practical applications of eddy currents, but in this video, I'm going to discuss only about the important uses of eddy currents. The first uses of eddy current is the induction furnace. Okay, so you know this heating effect of eddy current, it is very useful to heat or to melt the metals. The substance to be heated is placed, in a very strong electromagnet. Suppose these are the metals, and I place them, in a very strong electromagnet, which means in a changing magnetic field. So because of this changing magnetic field, then the magnetic flux, right, will change. So this changing magnetic flux in turns will induce eddy current in this metal. And that eddy current, it is, right, producing so large. I mean, the eddy current will produce a heat in each of these metal, and the heat, it is so large that it can even melt the metal, and as a result, right, we will get an alloy. Okay, so this is about the first applications of eddy currents. The second applications of eddy current is electromagnetic damping. Okay, so if you remember, in a moving coil galvanometer, we have a rectangular loop, and this rectangular loop, it is placed between two pole pieces of a horseshoe magnet, north pole, south pole, and this horseshoe magnet produce a magnetic field. All right, so what happens is, as the coil move in this case in the magnetic field, then current will be set up in the coil, and this current, it is known as the eddy current. So this eddy current will stop the oscillations of the moving coil. So which means the oscillations of the coil are damped. So this is called electromagnetic damping. Okay, all right. Now, the third application is electric brakes. Okay, So, eddy currents can be used to reduce the speed of an electric train. So in order to reduce the speed of the electric trains, what we do is we apply an electromagnet to the wheels of the train. So if this is the wheel of the train, and if there is an electromagnet, okay, that means there will be, as the wheel rotates, so the magnetic flux linking with this wheel will change. So that changing magnetic flux will induce what? A large eddy current in the wheel. And this eddy current will in turn stop the motions of the wheel. So this is how we use, eddy currents to, to stop the electric trains, or we can say in the electric brakes. Okay. The fourth use is energy meter. So outside your home, you always have an electric meter. So in that electric meter, when you look carefully, you will find, a circular disc. And this circular disc is aluminum disc. And this circular disc here, it is placed between two pole pieces of a strong electromagnet, like this. Now again, you will get a magnetic field which is coming from North Pole to South Pole. So as the disc circulate in this case, then what happens? The disc will cross the magnetic field. So because the disc cross the magnetic field, then the magnetic flux which is linking with the disc will change. So because of that changing magnetic flux, then you will find that eddy currents will be produced in the disc. And this eddy current, right, it will oppose the motions of the disc. Okay, so this is how an eddy current is used in the in the energy meter. Okay, so this is about eddy current, all right, undesirable effects, minimization, and uses of eddy current.